All right. 4-7. Quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. That's a c right there. Let me rewrite that. AC over 2a. What does that mean? We have factored before. I've given you things like this: x squared minus 2x plus 1, and we factored that out to come out with x minus 1 and x minus 1. Okay? We've done stuff like that before. You're going to run into situations where you can't factor it easily. Let me give you an example. X squared minus 10x plus, let's say, 20. Okay? To try and figure out, if we went and try and figured this out, we'd say, well, we could factor these into 1 and 20, 2 and 10, 4 and 5, and none of them would add up, because that's what this add here means, would add up to 10. So we really don't have a good way of being able to factor these. So what do? We need to take this and put this into the quadratic formula. Quadratic formula is based off of this: ax squared plus bx plus c. All right? This coefficient out in front of the x squared is your a. The coefficient out in front of the x is your b, and then your constant down at the end is c. That's where they come from. Okay? So if we take this now and we plug this into this formula here, we can figure out what our x's are going to be. So let's try it once. X is going to equal a negative b. Now we've got a negative 10 here, so this is just going to be 10, plus or minus the square root of b squared, which is 100, minus 4 times a. A is 1, and c is 20, so this would be minus 80, over 2 times 1, which is just 2. Okay? So x equals 10 plus or minus the square root of 20 over 2. Oops. Over 2. And now it comes down to, what's the matter, Preston? Stop. Do you get this? X equal 10 plus or minus, we can pull a 4 out of this. All right, we make this 4 times 5, and 4 is a square root, so this comes out square root of 5 over 2. And now we can divide 2 out of all these. And we come up with x equals 5 plus or minus the square root of 5. So if we were going to break these out, what is the square root of 5? Anybody got a calculator going? Tell me what that number is, thereabouts. Two point 2.7? Yeah, well, 2.6 we'll use. Sorry, bud. 5 minus 2.6, and x equals 5 plus 2.6. That's where this plus or minus comes in, right here. All right? Sort of plus or minus here comes in, so we can subtract that out. So we can say that x is equal to 2.4 and x is equal to 7.6. And that's how we use the quadratic formula to be able to figure out how to factor this out here. X squared minus 10x plus 20. Well, it really is. What did I do here? All I did was really plug the numbers in and it just did algebra, right? That's all I really did. Pretty easy? I don't think so. Squared plus 12x minus, let's say 20. Again. Can we figure out what that is? Grab a piece of paper out. Grab a piece of paper out. And let's see you do it. Can you ever come up with an imaginary number? Do you know how to do this? What would happen if I had an imaginary number? No, there's a solution. That's just imaginary. But how would I get an imaginary number in there? A negative where? In the square root, right? If I had a negative in that square root, I could have an imaginary number. Stop that. I know. What's this going to look like, Trev? Or Fletcher? 6x? What? How am I going to set this up? Remember. Okay. Remember, I'm going to write this bigger right here. Equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what am I going to do first? X equals what? Negative 12 plus or minus square root, which is 144. Minus 4 times 1 times negative 20, right? So we'd do plus 80 over 2. Okay? X would equal negative 12. So all we've done here is we just filled in this portion. That's all we did. We just filled in this portion of the quadratic formula. So we go negative 12 plus or minus the square root of 224. Over 2. 224. Got to break out a calculator for this. Because I know we can take part of that, we can factor out something out of 224, and my guess is 16 is going to be able to come out of there. Reason why I say 16? I don't know, maybe not. Maybe not. Maybe it won't. Divided by 4. Divided by 4. Yeah. All right, we can take 16. If we take 224 and divide it by 16, why would I use 16? Because I know it's a square root. It's a perfect square, right? So I'm going to try that. I can take that, and I'm left with 14. Just to show you how this looks, minus 12 plus or minus square root of 16 times 14. Okay? Over 2. That's a 224. I can take a 4 out of this now, right? Or 16. I can take 16 out, and the square root of 16 is 4. So x equals minus 12 plus or minus 4, because that's what I square rooted 16, left with square root of 14 all over 2. Now I can take it. What? Go ahead. No, because it's in the square root. All right, you can't do that. So now I can take this out. Now I can say x equals 2 divided into 12 is a minus 6, plus or minus, and into this would be 2 square roots of 14. So what I did is I divided my 2 into both of those. And now I can come up and say minus 6, minus 6. Let's say plus 2 times, where's my square root? Square root of 2. This equals a negative 3.17. So I went, let's see, 3.17. And then I do my negative 6 minus 2 times square root of 2. So minus 8.83. 8.83. Those are my 2. I'm able to use the quadratic formula to be able to figure that out. So we've used stuff that has a 1 out here, right? Let's do one with a number out front. Let's say 3x minus, or 3x squared minus 12x plus 16. It may factor out in the even numbers too. We don't know that. But trying to factor this one here is a little tougher than if we, just had a regular x squared out in front. So let's try it once. X equals b minus b, which is 12, plus or minus the square root of b squared, which is 144. All right. Minus 4 times 3, which is 12. Oh, this is going to be a big number. This will give us an imaginary number. Right? 4 times 3 times 16. 192. Over 2 times a, which is 6. Yes, you can come up with an imaginary number. If you come up with an imaginary number in here, then you leave it as imaginary. So this would be 12 plus or minus square root of, what's that? It's 48 negative over 6. We can pull that I out. 12 plus or minus I square root of 48 over 6. And now we can pull out a 4 out of that, actually 16 out of that, right? 16 goes in the 48, is that right? Yes, 3 times. Yep. So we can make this 12 plus or minus 3 times. This is 3 times 16 times 3 in here. So I'm going to pull that 16 out. That's an I. That means it's an imaginary number. Because we can't take the square root of a negative, can we? Over 6. Divide 2 in each one of these. And we have 6 plus or minus 2I square root of 3 over 3. And that's as far as you can go with it. So what I basically did here is I plugged in my numbers. I came up with this right here. And then I just reduced it. Okay? I reduced it down to that right there. I do want you guys to know how to reduce. What's that? Yeah, you have to figure out what you can take out of it that's a perfect square to be able to reduce it down. If you have a negative in there, pull it out, make it an I on the outside. Okay? Nick, got it? Okay. One through 6. I just want you guys to be able to use a quadratic formula to figure these out. All right? Plug them in. Do you want to do the other page too? Just going to play it. All right, chapter 4. Yeah, did that last time too. All right. Take a look at the other page ones. Well, you asked about it, so let's take a look. Oh, look at all these. Look at all these. Okay, you can do the evens. Evens. Just do the other page. Do the 1 through 6 on the other page. All right.